In this video, we're going to look at solving linear inequalities, which is very similar to solving linear equations with a couple differences that I would like to highlight. So first of all, let's go ahead and define what we mean by a linear inequality. When we talk about an inequality, we're talking about if two things are not equal, then there's a relationship between those two things. Maybe one thing is less than the other thing, or another thing is greater than something else. We also throw in there less than or equal to, greater than or equal to, and sometimes you'll see not equal to as an inequality. But we're just going to focus on inequalities of these four variations right here. So let's recall something that we already know how to do. Let's say we have an equation, all right? 2x equals 4. Hopefully you know how to do this. 2 times what equals 4. This is a linear equation, not a linear inequality. Okay, so the answer to this is x equals 2, right? There's only one possible value that I could put in here for x that would make this true. 2 times what is 4? The only thing that makes that true is 2. So the difference between a linear equation and a linear inequality is I might say something like this. Okay, so pick a value of x so that 2 times x is bigger than 4. So let's just guess and check. Let's just brainstorm here a little bit. What are some values of x that would make this true? Okay, well if x was 2, if I picked x to be 2, I'd have 2 times 2, and that's not greater than 4. Alright, so 2 doesn't work. What if I pick x to be 3? Alright, 2 times 3 is 6, which is greater than 4, so x could be 3. What if I picked x to be 4? 2 times 4 is 8, which is greater than 4. Alright, so 4 works. That one works, that one works, that one doesn't work. Alright, so x could be 4. Hopefully you can kind of see the pattern here. If I pick x to be 5, 2 times 5 is 10, which is bigger than 4. So 5 works for x. And as a matter of fact, there are infinitely many values that will work for x. We could keep going, 5, 6, 7. But we haven't talked about decimals, right? There are decimal numbers that will work as well. So let's say we said x was 2.1. 2 times 2.1, is that bigger than 4? Let's see, 2 times 2.1 is 4.2, which is bigger than 4. So x could also be 2.1. We know if x is 2, it doesn't work. So hopefully you're seeing here that x has to be, if x is just a little bit bigger than 2, it'll work. And that gives you the values of x that are the solution to the inequality. So one of the big differences between linear inequalities and linear equations is that linear inequalities can have infinitely many answers. All right, so what we basically discovered here is any, let me write it up here, any x bigger than 2 will work. Okay, so that's kind of writing it out in words. But let's say I wanted to write this as an inequality, any x bigger than 2. Let me get rid of these since we have that information over here. There's another way I can write any x bigger than 2 or greater than 2, and that would be any x greater than 2. Okay, so that's another way I could write the solution. Now notice, if I start with this inequality right here, and I do the same thing I would do if it was an equation. If it was an equation, I would divide both sides by 2 and get my answer. If I do the same thing over here, and I divide both sides by 2, what do I end up with? I end up with x is greater than 2, which we know is the solution. So in most cases, I'm going to show you the exception here in a minute. In most cases, you can solve a linear inequality the same way you solve a linear equality, by doing things to both sides. Okay, so you're basically using a rule that says, you know, if A is greater than B, then if you add the same thing to both sides, A plus C and B plus C, then the left-hand side will still be greater than the right-hand side. So you're using the same kind of properties you used if it was an equation. All right, so let's see here. How do we express our answer? Well, this is one way to express our answer, x is greater than 2. Another thing we might want to do is graph our solutions on a number line, which is why I have a number line here. So if I wanted to put all the values of x that make my inequality true, I'm going to put all my solutions on this number line. I need to graph all the values of x that are bigger than 2. All right, so those are over here. Anything bigger than 2 would be over here, but I don't want to include 2. So there's generally two different notations for this. X is bigger than 2, right? I want all the numbers bigger than 2. So I want all these numbers here, all these numbers forever this way, and I want to get really close to 2 but not exactly touch 2. So the two different notations that I've seen that show that are by putting an open circle on 2, by showing I'm not including 2. Just x is bigger to 2 but not including 2. Some books I've seen use this notation. They use a parenthesis and then an arrow like that to say x is bigger than 2. Okay. Before we go on and look at some other examples, let's write down all the different ways that we could graph this, the different types of graphing. So let me take this away here. And this guy, so this number line right here is giving us the solution to x is bigger than 2. What if I had an answer that came out to be x is bigger than or equal to 2? What if my answer came out like this? Okay, an example of that would be if we would have started with 2 times x is greater than or equal to 4, and we were to solve that. We would divide both sides by 2, and we would come up with x is greater than or equal to 2. So the way that we do that on the number line, instead of using an open circle, we use a closed circle to include 2, and then anything bigger than 2. In the other type of notation, and you'll just have to see what your instructor requires of you. Hopefully your instructor would take both of these notations because they're both valid. Instead of a parenthesis, if you want to include 2, you use a bracket. Okay? So if there's an equal to part, you use the closed circle or the bracket. If there's not the equal to part, you use an open circle or a parenthesis, one of those two notations. Okay, now a third type of way to express this answer is something called interval notation. Let's do that in blue. So with interval notation, you're going to write your answer by first writing the smallest possible value, or the lower boundary. I'll just say smallest value for now, and then a comma, and then the largest value. Oops, I didn't do that right. Let's try that again. Largest value. All right, so and then you're going to either use a parenthesis or a bracket, or a parenthesis or a bracket. Okay, I know that's a little confusing, so let's look at an example. So up here for interval notation, the smallest value of x that I could use has to be a little bigger than 2. So like I said, in some cases you could think of the smallest value as the lower boundary. So I can't get any lower than 2. So for my interval notation, I'm going to start with a 2. And then I don't want to include 2, so I'm going to use a parenthesis, just like I use the parenthesis here. And then I do a comma, and what's the largest value of x that will work? Well, x goes to infinity, so there is no largest value of x, so I write the infinity symbol. So this means x could go from 2 up to infinity. And generally with infinity, you use a parenthesis here, because you can't get to infinity. Some books use a bracket there. Hopefully your instructor wouldn't be too picky about whether you use a bracket or a parenthesis with the infinity. But you have to use a parenthesis if you don't want to include 2, just like you have to use a parenthesis on the line if you don't want to include 2. Now if I want x is greater than or equal to 2, I'm going to do the same thing for my interval notation. My lowest value is 2, but now I want to include 2, so I'm going to write a bracket, and then comma, and then all my x's still go to infinity, and that would be the interval notation. So this is one of the big differences when you're solving inequalities, is there's a lot of different ways to write the answer. All right, you've got interval notation, you've got a line graph, and then you've just got the answer here, you know, we'll call it inequality notation. X is greater than 2. There's another notation called set builder notation. I don't think I'll include that in this video. Maybe a separate video I'll do for set builder notation. So look for that if you need help with set builder notation. Okay, let's look at another example. Now that we kind of have an idea about all the different ways we can write this, let's look at a linear inequality that takes a few more steps to solve. Let's pull another line graph in here for our solution. Let's do one that requires a few more steps. How about 3/4 x minus 1 is less than or equal to, oh, how about 7? Actually, let's do 8. Less than or equal to 8. Make it come out nice. Okay, so if this was an equal sign here instead of a less than or equal to, what would you do first? Right? You'd add 1 to both sides. You're going to do the same exact thing here. We're going to add 1 to both sides. And so that gives us 3/4 x is less than or equal to 9. Just make sure you copy this sign down, less than or equal to. Now to solve this and get x by itself, if that was an equal sign, I would either divide by 3/4 or multiply by the reciprocal. So I'm going to do the same thing here. And that gives me x is less than or equal to 9 times 4 is 36, divided by 3 is 12. Okay, x is less than or equal to 12. Maybe I should make up a different number line since I don't have 12 on my number line. I can get rid of these. So let's graph this on our number line, and so if you had to write a number line, you could just start with something like this, and since 12 is an important number for our graph, just put it in the middle there somewhere, and then, you can just label these however you want. That should be good enough. All right, so where are the x's that are less than or equal to 12? Well, they're going to be down here. These are the values so you're graphing your solutions. So now, do I want to use a parenthesis or a bracket on my number line? I'm going to use a parenthesis, one of these two parentheses going this way or this way if I have, not the equal to part, if I have just less than or greater than, and I'm going to use a bracket, depending on which way I want to go, if I have the equal to part. So in this case, I have the equal to part, so I'm going to use a bracket, and I want to go less than 12, so I'm going to have my bracket facing this way to go less than 12. So here's all the numbers less than or equal to 12, and the bracket tells me that I want to include 12 in my solution, equal to 12. So the other notation, if you wanted to use the open circle, closed circle, since it's an equal to part, you're going to use the closed circle. All right, and here you're going to use, you're going to use the open circle if you didn't have the equal to part. You'd use the open circle. So I'd start at 12, I'd do a closed circle, I want to include 12. 12 is part of my solution, and then everything less than 12. Now I just went above the number line so you could see it, although I'm doing it in red so you could see it anyway, but when I get work from students and then it's like pencil on top of the number line, sometimes you can't see it, so you could write it right above the number line. Alright, what would this look like in interval notation? What would this look like in interval notation? Okay, what's my smallest value of x that's going to work? Well, x goes forever negative. There is no smallest value, so when that happens we write negative infinity. That's where we're going to start. And then we put a comma, and what's my largest value of x? Well, it's going to go all the way up to 12. Now, do I want to include 12 or not include 12? If I want to include 12, I'm going to use a bracket. Okay, and that's interval notation. So we have 3 different ways we can express our answer. On a number line, with our x is less than or equal to 12, or with interval notation. And like I said, set builder notation is another method that I'll post a video on later. Okay, one thing I want to highlight here is how you could check some of your answers. Remember, this was our original equation, 3/4 times x, I'm going to leave that blank, minus 1 is less than or equal to 8. So what we're saying on this number line is any number we pick that's less than 12 will make this statement true. Okay, so let's pick some number less than 12. I'm going to pick an easy one. I'm going to pick 0. Let's say I let x be 0. Okay, 0 is certainly less than or equal to 12. Well, what do I get? 3/4 times 0 is 0, minus 1 is negative 1. I come up with this statement, negative 1 is less than 8. That's true. Okay, so 0 is a solution. We could pick any number less than 12, and it should make this statement true. That's what makes it a solution to the inequality. Let's pick negative 4. That's less than 12. Let's see what we get. What do we get on the left-hand side? See, these 4's will cancel to be 1, so we're going to get negative 3 minus 1, which is negative 4, and that is less than or equal to 8. That's true. So that means negative 4 is a solution to our inequality. Lastly, let's pick one that shouldn't work. What's a value of x that, if I put it in here, should make this statement false? Well, any value up here, any value that's bigger than 12 should make this false. Let's try 20. I'm picking numbers that I can cancel this 4 with, so the arithmetic's easier. All right, 4 goes into 25 times 3 is 15. Or you could do 3 times 20 is 60, divided by 4 is 15. So I would get 15 take away 1 is less than or equal to 8. So I would get 14 is less than or equal to 8. That's not true. All right, so therefore 20 is not a solution. What are all the values of x that make this inequality true? Any value of x less than or equal to 12 will make this true. All right, there are infinitely many solutions to this inequality. So the good news is you're going to solve these the same exact way you solve them if it was an equal sign. That's really the good news. Okay. The new stuff is the interval notation, which takes a little getting used to, and the line graph, which most students pick up on pretty quickly. Okay, well, you know mathematics. There's always a little fly in the ointment, right? It can't be that easy. So there is one very large exception to this whole deal of just solve it like you would if it was an equal sign. Okay, let me show you what that exception is. Let me show you without variables. Let me show you without variables because I think that's a real powerful way to look at it. Let's start with a true statement. Let's say I say 3 is less than 5. Everybody agrees with that, right? So if I add 1 to both sides, add 1, oops, I wrote add twice, add 1, I end up with another statement which is 4 is less than 6. That's true. Okay, so if I add 1 to both sides, I end up with a true statement. Let's say I divide both sides by 3. Okay, what do I end up with? I end up with 1 is less than 5/3, which is 1 2/3. Certainly true, all right? Happy, happy. So we're using this idea that what you do to one side, you do to the other, and it's all good. These are the concepts we learned when we were solving linear equations. Okay, here comes the fly in the ointment. What if I take this thing and I multiply both sides by -2? If I multiply by -2, I end up with -6 is less than -10. That, my friends, is not true. We have a problem here. Okay, so multiplying both sides by a negative results in a statement that's not true. But I could make it true. If I multiplied both sides, that was a positive. If I multiply both sides by -2, I can still do that if I need to. But in order to make the statement true, I am going to have to flip the inequality sign. Okay? So let's say you're solving an equation like, or an inequality like -2. Well, let's do -1/2 x is less than 6. Okay? So if you were going to solve this, you would multiply both sides by -2 to cancel that. Okay, you can still do that. You can still multiply both sides by -2. But just like over here, in order to make this a true statement now, you're going to have to flip the sign. So instead of less than, it becomes greater than. So your answers are going to be anything bigger than -12. And you could check that. You could pick a number bigger than -12, like 0. Okay, so if I put 0 in there for x, I would get -1/2 times 0 is less than 6, which is true. If you don't flip that sign, you're not going to get the right answers. Okay, so let's write this down. And it's also going to be true for dividing. I'll show you that here in a minute. So this is the big new concept here. If you multiply or divide, I'll just abbreviate there, okay? Multiply or divide both sides of an inequality. Oh my goodness. I think my hand's getting tired here. Okay, of an inequality by a negative, then you need to flip the sign. Flip the sign. Flip the inequality sign. Okay? So solve it just like you would normally, but if you multiply or divide both sides of an inequality by a negative, you need to flip the sign. Let's try one more of those where you might have to divide. I'll give you a real easy one. Negative 3x plus 1 is greater than or equal to 13. Alright, if you want to pause the video and try to solve this, give it a whirl. So how would we solve this? Well, we would start by subtracting 1. Okay, no problem. Just leave everything how it is. Leave that as a greater than or equal to, and that gives us 12. Now I'm dividing by a negative 3. Ding, ding, ding. I have to remember this right here. If I multiply or divide by a negative, I have to flip the sign. So I'm going to change this to x is less than or equal to negative 4. Okay, so there's my solution. X is less than or equal to negative 4. What would that look like on a number line if I needed to graph it? Less than negative 4 is going to be down here. Less than or equal to, I'm going to use the closed circle or the bracket. What should we use? Let's use the closed circle. I kind of like the closed circle. It's kind of tidy. All right? Closed circle, less than 4. So the other way to do it would be to do a bracket at negative 4 and then that way. How about interval notation? Okay, so since it's going all the way to negative infinity, you're going to start with negative infinity, and you're going to go up to negative 4. Do you want to include negative 4 or not? Yes, you do, because it has this equal to part, so you're going to use a bracket. So that would be the answer in interval notation. Now you can avoid this whole pothole here in most cases, in a lot of cases, by simply keeping your x term positive. In this example, we were stuck with the negative 3 times x. We were going to probably have to divide by negative 3 at the end, which means we couldn't avoid the pothole very easily. But in most problems, you can avoid it. So let me show you what I mean by that. Let's say you have something like 2x plus 5 is greater than 7x minus 3. All right, so notice we've got x's on both sides of the inequality. So my two options are here. I could subtract 7x from both sides to get my x's on the same side. But if I do that, I'm going to end up with negative 5x over here, which means I'm going to end up dividing by negative 5 at the end. And we know that if we divide by a negative, we have to flip the sign, and maybe we'll forget to do that. So instead, why don't we subtract 2x from both sides? And if we do that, then we end up with 5 is greater than 5x minus 3, and we won't have to divide by a negative at the end. If you keep this x term coefficient positive, you won't have to worry about multiplying or flipping the sign. Let's go ahead and finish this. We're going to get a fraction. We haven't done a fraction one yet. Here I'm dividing by 5. All right, no, it's not dividing by a negative, so I don't have to worry about it. So I get 1 3/5 is greater than x. Oh, I'm glad we did this one because a lot of people are used to having the x on the left-hand side, and it kind of messes them up when the x is on the right-hand side. So my x's, Well, 1 3/5 is greater than all my x's. So that means, another way we could think of this is that my x's, this means that my x's are less than 1 3/5. If 1 3/5 is bigger than x, that means my x's are less than 1 3/5. So if you're doing a problem like this on a number line, you might have to like put a little line here like this and just guesstimate where 3/5 is. And then I want everything less than 1 3/5, so I will use a open circle because I'm not including it. There's no equal to part, and then I'll go that way. Interval notation would be negative infinity up to 1 3/5, and I don't want to include 1 3/5. There's no equal to part, so I use a parenthesis, and that would be the interval notation. So just to finish off, let's do this exact problem the other way so you can see the answer comes out to be the same. Oh, are you going to get finicky now with me? There we go. Okay, so let's do this exact problem, except let's start by subtracting 7x so you can see it comes out exactly the same. I think it's worth looking at. Exact problem. Let's start by subtracting 7x. So that would give us negative 5x plus 5 is greater than negative 3. Lots of negatives this way, so we would subtract 5 from both sides. Still legal. So we get negative 5x. I subtracted, so I don't have to flip the sign. I only have to flip the sign if I multiply or divide by a negative. Here we go. I'm dividing by negative 5. So since I divided by a negative, I have to flip the sign. So instead of greater than, I'm going to flip it to less than. Negative divided by a negative is a positive, so I end up with x is less than positive 1 3/5, which is exactly the same thing we got over here. Okay, so you can still get the right answer no matter which way you do it. But if you want to avoid or try to avoid this little pothole here, then keep your x term positive and you won't have to worry about it. So hopefully you get used to interval notation and graphing things on a number line, and then solving inequalities is a lot like solving linear equalities.